In this video, we're going to talk about the pH scale. So first, let's talk about what pH is. So when we talk about pH, we're talking about the concentration of hydrogen ions. And remember, a hydrogen ion is just a single proton. So we're talking about the concentration of hydrogen ions in a solution. And we're going to measure this in moles per liter. If you don't understand what moles per liter is, that's okay. You don't need to know what that means at this point in the course. You just need to know that we're measuring the concentration of hydrogen ions in a solution. All right, so let's look at this equation relating our concentration of hydrogen ions in moles per liter to pH. So we have this equation of hydrogen ion concentration equals 1 over 10 to the power of pH. So we have 1 over 10 to the power of pH. So let's say we have a pH of 3 here, okay? So this is going to equal 1 over 1,000, which is going to be 0.001 moles per liter. All right, so let's take a look at another example. So what if we have a pH of 4 now? So first we had a pH of 3. Now let's look at a pH of 4. We have 1 over 10 to the 4th, because we have 1 over 10 to the power of pH. Our pH is 4. So 10 to the 4th equals 1 over 10,000, which is going to be 0.0001 moles per liter. All right, so what do you notice here? We had a pH of 3, and then we had a pH of 4, and our concentration went down as our pH went up. So we have a lower concentration with this pH of 4 than we did when we had a pH of 3. Okay, and you can see these are inversely related. So when we have a low pH, we are going to have a high hydrogen concentration. When we have a high pH, we are going to have a low hydrogen ion concentration. Now, what does hydrogen ion concentration have to do with anything? Well, our hydrogen ion concentration is going to determine if the solution is acidic or basic. If we have a high concentration of hydrogen ions, our solution is acidic. So we have an acidic solution if we have a high concentration of hydrogen ions. If we have a low concentration of hydrogen ions, then our solution is basic or alkaline. Those two words can be used interchangeably, basic and alkaline. All right, so let's review what we've gone over. So if we have a low pH, then we're going to have a high hydrogen ion concentration. And you can remember that these two are opposites of each other. If we have low of one, then we're going to have high of another. So low pH, high hydrogen ion concentration. And that's going to mean that our solution is acidic. If we have a high pH, then we are going to have a low hydrogen ion concentration. Remember, these two have to be opposites of each other. High pH, low hydrogen ion concentration. And that's going to make our substance basic or alkaline. Now let's take a look at the pH scale and some examples of some substances. Let's see where they fall on the pH scale. So first, let's take a look at water. Water has a pH of 7, so it is going to be neutral. It is neither acidic nor alkaline or basic. So water has a pH of 7. It's right in the middle because our pH scale goes from 0 to 14. So 7's right here in the middle. Battery acid is going to be all the way at 0 on our pH scale. So let's take a look at our equation. Let's put in 0 for our pH. So we have 1 over 10 to the 0. It's going to equal 1 over 1, which equals 1 mole per liter. So this is a very high concentration of hydrogen ions. This is going to be very acidic. Battery acid with its pH of 0 is as acidic as you can get. Lemon juice is going to have a pH of 2. So it's going to be less acidic than our battery acid. But lemon juice, as you well know, is still very acidic. It's a very acidic substance. Bananas are going to have a pH of about 4. So while they are less acidic than lemon juice, bananas are also still acidic. And then we had water at 7. Remember, water is a neutral substance. It's not acidic, It's not basic or alkaline. Water is neutral. Egg white is going to be right here at 9 with its pH of 9. And let's take a look at an example. Let's see what our hydrogen ion concentration in moles per liter is going to be for egg white with its pH of 9. So we have 1 over 10 to the 9th power. And that's going to be 0.000000001 moles per liter. So we have a very low concentration of our hydrogen ions right here. Ammonia is going to have a pH of 11, so it's also going to have an even lower concentration of hydrogen ions. It's going to be pretty basic, pretty alkaline. And then we have drain cleaner with its pH of 14. And I'm not going to write this out, but just know there will be a lot of zeros here. This is going to be a very alkaline solution, a very alkaline substance. It's as alkaline as you can get. And that's going to be because it has a very low concentration of those hydrogen ions.